Hi everyone, welcome to another episode of the Lisp Study Group. I'm your host Ron Batum with Atlanta Functional Programming. The last couple of weeks we've been covering various experiments that I've been doing with CFFI, one of which, as we saw last week, was the ability to write bindings for a Go library that I wrote in CFFI that uses a simple primitive types. I restricted myself to just kind of integers, longs, and so forth, and strings. And we saw with strings, especially last week, that you'd be able to you'd require some type translators to translate between Go strings and Lisp strings and so forth. And there's some limitations, especially with how the buffer is actually being encapsulated behind the scenes with Go, but we're able to handle that with some, what I would say, limited but equally additional restrictions in our type translator that allow us to at least get exactly what we're getting from the Lisp string thanks to the information that Go is providing us. I also mentioned last week that Go strings are Unicode as well, but we didn't have time to actually cover that. Hopefully in a future session we'll be able to also talk about how Unicode kind of works and maybe even be able to try some examples with that, but I haven't had a chance to actually do some of those experiments. But I thought I'd let you know that both SBCL and I think most modern Lisps now do support UTF-8 internally. And there are a couple of libraries out there also that gives you some nice ability to handle runes too as well, with UTF-8 encoded strings too. So that gives you some flexibility to actually work around depending upon what Lisp you're actually using. I ended last week also with this example that I'm kind of presenting to you today, which is an ability to call Lisp code from C code with at least SBCL specific things. So we encountered something like this where you may have a define alien callable, which is an SBCL specific API, part of the SBAlien package. So you could define a alien function that is exported into a library that can be called through a core file that is loaded into a SBCL process that's embedded inside of an application. The use case being, of course, that you have an existing Lisp API that you'd want to be able to use in other applications in this, mixed programming, a mixed language sort of environment. So this way you don't have to retest in some cases, requalify in other cases your algorithms and so forth, and you can actually use the Lisp library as is from within your C application. I mentioned that given the techniques that we did with the Go example, that it is very well the case that if you have a Lisp library written in this form, then the possibility of you being able to load it in other languages as long as they adhere to the C API is possible. We saw last week that we ended last week with a discussion and actually a session where basically I attempted to execute this inside of an existing C function file that I've written called mymap.c that basically loaded the Lisp into a session, passing the appropriate arguments that would normally be passed inside of that Lisp session, along with one of our core file that we created, and just to see if we can actually initialize it. And we ended up encountering I'll just show you this simple example of when you actually provide, when you actually provide the library path. This is in actually home, software projects, Lisp projects, SBCL, source runtime. This is where if you compiled the SBCL library has a shared object, which I mentioned that you would need to in order to actually encounter this, and unfortunately it's unavailable as far as I could tell in most Linux distributions. hopefully maybe someday, but not on Debian 11 at least. It's not available. If you try running our code, our example thing, you end up getting, hold on one second. Did I mess this up? Hold on. This is because I ended up writing, one second. Oh, I'm in the wrong session. Sorry. That's the reason. I'm in CD. Do this. Project, those projects. My math. Okay. We tried running this, we ended up getting this error, which basically is telling us that it's unable to find this foreign function that was part of the SBAlien package that is required to actually call into Lisp and look up particularly the alien symbols that we've interned when we compiled and dumped out the core file from mymap.lisp. Okay. So I thought I would at least start with explaining to you what this alien variable is and kind of some updates, and then we can move on with the main topic of today's discussion, which is SBCL-Librarian. Mainly because, unfortunately, I realized when I was reading the SBAlien documentation, as you will later on understand, there's some stuff related to this setup that SBCL-Librarian actually went through the pains of actually fixing. So I thought I would at least start with that and then show you what you need to do behind the scenes to actually do it vanilla if you really don't want to depend on that dependency. So I'm kind of reversing the agenda today just so that we could see why you would probably use a library or a tool like SBCL-Librarian, because unfortunately this particular use case is still fairly new. I believe this ability to compile it has a shared object, SBCL has a shared object, came out only 4 years ago, and it's not as well documented as I thought it would be. Of course, if anybody in the SBCL community is watching this, can point me into some direction, I'm most certainly will run it by this stream. I just didn't see enough information for that particular use case. But the nice folks from the SBCL-Librarian package kind of went through the pains to actually take care of this for us. So we'll start with that in a bit. But first, what does this undefined alien variable error mean? So when you are dealing with foreign code inside SBCL in general, when you're loading that foreign code into SBCL, there's something called the linkage table that is actually required to hold this foreign code so that when it gets loaded into memory, whether it's through a core dump or what have you, you'll be able to actually figure out the memory addresses where these foreign functions reside. So this way, when you actually encounter it through this V8 mapping that is normally done through assembly code, it will be able to encounter that particular section of memory where the shared library resides and actually go and invoke the function. This is essentially equivalent of having the DLSIM return value that you would normally deal with when you're loading libraries inside the C being actually available in the core. And in fact, that DLSIM approach is what was traditionally done when you were using SBCL's, I guess, spiritual predecessor now, because it kind of done a lot of stuff different from its original fork, from CMUCL. So if you ever use CMUCL, that's exactly what they do. They actually, for foreign code, essentially do a DLL open or a DL open to load the shared object into memory, and then use DLSIM to take the objects that are in the locations of those memory and dump those locations from the shared object into the Lisp core, so upon reload, they are back at those fixed locations. Okay. Why am I explaining all this to you? Well, it's important to realize that that same approach is actually also leveraged when we're exporting functions from Lisp into Lisp core, because effectively what we're trying to do is make an entry in that table to say, hey, instead of actually calling out to this foreign code, we are a foreign interface, we're redispatching to a Lisp function. So it's using the same infrastructure there. Unfortunately, from at least what I've attempted to do, which is just do a simple export as you saw before, this doesn't seem to be enough to actually go and just do a save Lisp and die and then do callable exports. So there was something kind of missing in the piece to actually encounter and deal with that specific this specific use case. Luckily for us, there is a library out there that dealt with this and figured out how to handle it and do it in a way that is somewhat portable. And that's the SBCL-Librarian package. SBCL-Librarian was created by a group of folks that is creating what's called the Quill language, and it's for quantum computing. And they heavily use SBCL. I encourage you guys to actually look at their projects and their project organization on GitHub. But what they've done is they've essentially created this nice little utility that allows you to expand and define an API in using their exported API. And you can then set it up using a simple makefile and the SBCL shared object to essentially load it into a C environment so that you could then leverage it inside your C applications. Additionally, they wrote some utilities to actually generate a exported Python module that you could allow you to use Lisp code with Python as an individual package without actually modifying the Lisp code. And this is using the same approach, but in addition to the C API exporting, they are leveraging the PyObject C API from CPython to actually go in and allow it to have a proper Python module. So I thought we'll go through the example that they provided, just mainly because I didn't have, unfortunately, enough time to generate a separate one for this. And then maybe on live we can actually go through and create our own version or extension of this with some simpler examples to kind of see how well their docs are, as well as how mature the library is. This is a fairly new project. It came out only in the last couple of years, but it looks like they've from the examples that I've tried, it's stable enough for us to at least have a conversation about it. So if folks who are watching have questions about the SBCL library and want to try it on their own, I did include in the side of the links where the library is located, so you can certainly take a look at that. Unfortunately, as far as I could tell, the library has not yet gone into Quicklisp. So for folks who are looking at it through system apropos in Quicklisp, I don't believe the library is available in Quicklisp, but we can always check that out here very quickly. I think the last time I tried this, it was not available. So system apropos, as you can see, it's not available. As usual, when you're using any libraries like this that is not inside Quicklisp, the one thing you'd want to do is load your libraries inside Quicklisp's local project directory inside of your local registry, so that way it's immediately available to you. Since I'm using Roswell, obviously that means I'd have to check out the project inside of .roswell/local projects, and Quicklisp will be able to recognize that package, and then you could just do quick load SBCL-Librarian, and you can load the package into your image. So, what does this package provide us? Well, I thought the easiest thing to do is to first show you libcalc.lisp, which is an example library that they wrote to build a calculator program. And then we can kind of go through this. One little thing for folks who are just joining in, these episodes are usually informal discussions. If you guys have any questions, feel free to drop them in the chat as I go along, and I will address them accordingly. I don't think I normally have to tell folks this, but I always have to remind myself as we start digging into it, just so that if newcomers are coming in, they can go in and drop their questions along the way. So let us get started here. Give me just 1 second. And this is right. And okay. So this is in examples. Give me just one second. Alright, so the one thing I thought would start with, instead of the calc example, is to kind of go through the example that was defined in the cookbook. Actually, this will probably be a bit better for us to do this. So in order for us to actually leverage this, we have to do a couple of things. First, we need to provide two things, which is in our shell, we're going to go ahead and do our shell here, eShell. We're going to first export two things. Give me a second here. Let me just do that. We're going to export our SBCL source, because we're going to, in a lot of the the code, the SBCL version of the shared object, its source code should be somewhat available to you, just because of the shared object being unavailable through any of your normal distribution centers. You're going to have to compile it yourself. And the SBCL-Librarian utility actually requires that the shared object be available, and if it isn't, it will actually attempt to compile it itself. And there's, in the make files in the examples, it actually has some of these instructions. So we'll probably leverage those just for the sake of our example. Although for now, since I've already compiled it, you don't necessarily have to worry about that just immediately. All right. So let's do this. Let me do this. I'll make a better running. I'll first go ahead and create hello librarian, okay, which is our standard hello world application. Go into this. SBCL. Okay, and then we're gonna go ahead and create our two environment variables. The first one being the location of SBCL. Now, since this is a GitHub repository, hold on, let me do that. There. That. Okay. And then I thought I'd just go ahead, just in case folks are interested. Let me just quickly do this. And let me just show you the branch that I'm doing. I'm using SBCL 2.4.2, which is the same version that is of the installed SBCL bin that I have for today's discussion. So if you're using Roswell, ideally this should actually work with Roswell. I have not yet figured out in Roswell what to use to actually go and compile the source. folks who are who knows that command, just please let me know, because this way, you know, I could do everything through Roswell. But I use these examples because of that limitation. I didn't see that being available. Okay, so we first have our SBCL source. What's the other example that we need to kind of like look for? Well, that is actually, we need to provide SBCL-Librarian with the location of the project, specifically for the purposes of actually loading our actual SBCL-Librarian checkout project. Luckily for us, since I put this into a local registry for Roswell, SBCL-Librarian doesn't necessarily need this because we're not using ASDF load system directly. But for folks who are using ASDF load system, it is important that you put this variable inside your package too as well, which is the location of local projects of SBCL-Librarian. Please note, in all paths I am actually providing the ending /, and that's because SBCL-Librarian build scripts, as well as some of the paths that are using inside of Lisp, require that ending / so they can distinguish between directories or not. Otherwise, they will not actually attach that / when they're trying to concatenate two different path names. Just 1 second. Okay. So, let's build inside of our code here. We're going to create a file called hello world.lisp, right? And let's go ahead and open up this file. The first thing we need to do is obviously load SBCL-Librarian if it doesn't exist. I would wrap this, dang it, not eval when condition. Eval when, here we go, compile top level, load top level, and execute, not executable, execute. Now, I'm going to use, unless we find the package, and the package designator is, I believe, SBCL-Librarian is the top level package name. We're just going to go ahead and load Librarian using Quicklisp. Alright? Alright. Okay. So we now loaded SBCL-Librarian. Because it's able to find this package, which you'll see if you do find package SBCL-Librarian, it's able to find it. It's going to go ahead and load it. So we now loaded SBCL-Librarian. We're going to create a quick package defining our actual library. All right. We're going to name this guy, lib hello world. Actually, lib hello is fine. Sorry, I still have not figured out how to get autocomplete to work the way I want it to. We need to specify our actual dependent libraries. All right, CL is usually what you'd want. If you want to actually do SBCL-Librarian, you can certainly do so. To also depend your library on it to make it easier. For the sake of today's example, I'm not going to do this, just mainly because of the fact that I want to distinguish the APIs so that you can actually see what is actually available to you for the time being. But certainly, when you're writing your own packages, please do this for convenience. All right. So let's do this. Okay. And let's do that. as usual, we're just going to go ahead and say lib hello mrs. Oops, sorry, that not mrs. I have to do this. Okay. mrs. Okay. So now in the lib hello package. So now we can actually go and define our API for this. Okay. Let's create a simple add function. Okay. Defun add AB. Okay, so we have our simple add function like we had before. Okay, this is going to actually be called. This is our external function. Okay, but for now, because this is available, this isn't actually going to be exported just yet. In order for us to do this, we're going to have to add a couple of things. Okay, the first thing is we need to specify an error type. All right. This is going to be an enum that's going to tell us whether it succeeded or failed. Okay, this is mainly so that this way, when we exit the Lisp functions or whatnot, the appropriate error code is passed over to us. So in a convenient way in our code. So on the C side, or if you're using Python, the Python side, you could certainly use these enums directly rather than actually saying 0 or 1. Alright, just some convenience to do this. So let's go ahead and create this error enumeration for ourselves. You don't necessarily need to do this, but I think it's best practice. Just go ahead and do this. The way to do this is we have in SBCL-Librarian something called define enutype. Okay, and this guy takes a name and the actual C type, and then we could go ahead and specify the actual members of this enumeration. Okay. One second. Okay, so let's go with this. We'll call this error type. Is the name of our font thing. On the C side, you could use error T or error T, depending on how much you want. And then we name our enumerations. Okay, the enumerations are going to be string integer combinations in this case. So here we'll do error success. Just going to actually do success or fail. Okay. Done. Okay. And we now have this. Obviously, when you do this, you could see that SBCL-Librarian type is actually dumping the type defs for us, and it's going to just go ahead and create the alien types information for us when it actually generates the appropriate C code. All right. This is not important for now, but it is something that you can certainly keep in mind. Like when you see the bindings, how the bindings are generating. This is part of how the bindings are getting generated. All right. So we've defined our enumeration. We need to also now create a map. All right. This is essentially like the type translators that we were talking about last week. In this, we're generating essentially, well, when we are getting this one thing, how does it map to Lisp conditions? Okay. So this way, the interaction between Lisp, in Lisp, we'll end up using conditions in the condition system. On the C side and the Python side, we return the appropriate errors. All right. So let's go ahead and do that. And with this, we do SBCL-Librarian, and it is defined, I think it's this guy, errormap, right? Yes, define errormap. and we're going to name this also the error map. It's going to take our error type to being error type. When there is no error, what does that mean? We're going to say it means 0, and then otherwise we're going to define the conditions. All right, and for each of these conditions, and this is just the catch-all, it takes in the condition, the error, and then it takes a lambda function. All right. And this lambda function is going to take in the specific condition that it encountered, and it will go ahead and allow you to leverage, what does this condition mean? How do you want to go and handle it? For our case, since we're only using success or fail, we can actually ignore this for the time being, and we'll just go ahead and return from the error map with 1. So for all errors, we're just going to go ahead and return 1. Obviously, as your library matures, this isn't just necessarily enough, but again, this is generating all the type conversion methods that we were talking about, and adding some methods regarding just how to map between the two when it's actually leveraging. But this is essentially how this kind of stuff works. These are all macros that we've encountered thus far. All right. So we've defined our errors. We defined our error mappings. Now we are at a point where we can actually go ahead and define an initial API that we could then export. Okay. To do this, we have to call SBCL-Librarian define API, and this takes in, as you can see, the name of the API, and you could call it libhello. The Cookbook has libhello API, has its example. If you go and look at the documentation, it really doesn't, at this point, it doesn't get exported as far as I can tell, but let's check it out. And then the first thing you need to do is you need to specify the error map, okay, and the function prefix, okay. The error map is the error map that we defined earlier, all right? This is just naming all of our error enumerations, right? The prefix is important because this is what is going to namespace your functions on the C side. Okay, I've mentioned this before in several other episodes, but I thought I'd reiterate it here. In C, we do not have namespaces. You have to prefix your things to namespace. Otherwise, you will have name conflicts because it is a single namespace. So we'll go ahead and do this and make that. And now we can actually go ahead and define our API. Our API contains both the types that we want to export as well as the functions. Now, if you want to actually generate comments to indicate these sections, because define API takes this specification and dumps it into the various formats that you want to do that I will shortly show you how to do. But this is essentially defining your specifications. So to write comments to indicate different sections, you can use something called in SBCL-Librarian literal, and this will essentially tell the define API function that I want you to dump this as it is. Since we're using C, we have to use C-style comments, so we're going to first define these to iterate our sections. So let's go ahead and define our literals to indicate our sections. exported types, exported functions is what I normally do, just so that I know what they are. There we go. Okay. So now here we can actually go and define our types, and types is indicated by what types that you want to do, and this can take in a list of types, I believe, or no, you don't need to actually list a type. You're going to have to, for each type, I believe you have to do this, type 1, type 2, and so forth. So here we're only going to do our error type, okay, and this is our error enum that we defined, and our functions that we're actually going to leverage is essentially what are the functions that are going to be get dumped, okay? And this uses the FFI leverage stuff that we've talked about earlier, okay? It uses the same kind of notation. The only difference is I believe in, no, actually, it's the exact same for the callables, and we'll see how this works. So we're defining a function here. This function is going to be named, what did I name it? Add, oops, undo. Add, and this takes in an int, and then just like libapi, you need to go and specify your notation with the background. Notice though, unlike the alien callable example that I saw earlier, we don't need to actually export. We don't have to define SBCL before the actual alien function, as it does here, and it will go ahead and leverage that. Okay, so this is our actual function definition. Here, I'll just give a quick comment. The function is function name, followed by return type. This is the format, and then followed by list of arguments. Okay. And here is argument name arg type pairs. Okay. You need to provide this. This is kind of the list is requiring. And this is the notation that you would end up having. So let's go ahead and compile that, load it. And what does this do? This is actually creating the alien callable stuff that I was talking about before. All right, but it's doing a lot more than just defining it. And as you can see here, this is what we kind of need to provide some additional stuff in order to actually get it to be loaded into our linkage table. Okay. In fact, I think that's all I really need. You know, this we'll try that just to see what needs to be done to actually go ahead and define our function earlier. It might have been just the initialize alien callable that we saw earlier. So we defined the generated source file, we defined the API. What's actually left there to do? Well, there's two other things you need to actually do. One is you need to tell the linkage rules to SBCL-Library, so when it dumps out the shared object, it knows how to export these functions. And to do that, you have to end up calling something called SBCL-Librarian define aggregate library. All right, and this will this is actually the main meat of the function. This up to this point here, this is just doing nothing more than defining our library for code generation for C and Python. So what that means is this will generate the appropriate header files that you could just then use as is. This is kind of one of the nice features of this library. You can just define your Lisp functions. specify essentially what do you want to export, and then it will code generate once we're done with defined bindings to actually give you what you want. Okay, but in order for it to do it, you need to do SBCL define aggregate library, and you need to specify the name of it. Okay, and let's say live hello world for this example now, because we want to have a separate name for it. Function linkage is going to be lib hello API. Okay, and you're going to define now the environment that it needs, which means you need to specify one second, hide this guy. Okay, and you need to specify what APIs are we actually exporting. All right, and here we need to define a couple of things. One is SBCL handles. These are for marshalling, as I understood what it's doing. You need to specify the environment, and this is holding all the symbols that we've kind of exported, the Lisp symbols itself. And then obviously we need to specify the API, the C API that we just created, which is the callables of the FFI functions. All right, and what this does is it generates a very nice thing that we would end up leveraging later on. But the main thing here is there's an internal thing called library that SBCL-Librarian keeps track of, that it's used for later on when we define the bindings. All right, and that's done in this final piece. What bindings do we want to actually build? All right, now currently, as I mentioned, SBCL-Librarian only exports C and Python, which could handle the majority of cases. I will say that, for Go and Rust, there are certain semantics that we could probably do, and you could probably extend this. I would encourage you guys to try and see if you can do pull requests to add these other languages in there. I most certainly will attempt to try and do so, to provide SBCL-Librarian this ability to generate bindings for these other languages. But this is essentially the meat of the discussion. Each language has its own binding function. So for default, if you're doing C and C++, you're just doing define bindings. I think it's no. Oh, sorry, not define. Build bindings. And you do lib hello and do that. You're specifying the path name here, as you can see, the directory. Obviously, we want also, since we're doing Python too, we could do build Python. Oh, sorry. Bindings. Okay. Do lib hello. And it takes the same directory. And what this does is this is what's actually going to go and generate those functions. Hold on. Did I put the name before incorrect? No, that's the package. What is the API name? The library name is Hello World. Okay, so this is both now generating. All right, now we need to actually call build, core, and die in to actually generate this Lisp core. All right. Now, as I mentioned, when I tried this before with normal vanilla SBAlien, I was getting some issues. But the comment that you could definitely see that you need to do is something like this. All right. obviously SBCL-Librarian here. And what this does is it will take our library, alright, it will specify the directory and whether or not we're going to have to compress it, and then you'll end up getting this error because if you try to run this in Slink, it's going to complain about it. Alright, so let's go ahead and leverage Roswell in the shell to actually go in and go. Let's do run here. Oh, right, because this is SBCL, okay, so I can do SBCL. Since we're using a different shared object than normal, what we would have to do is we're going to have to run this inside the shell by calling out to run SBCL-sh to actually go and dump this. Alright, so to do this, we just simply do oh, okay, this is probably going to cause some issues, but we will see. Let's see. I'm going to have to do this. If I'm going to do this, I can't use Quicklisp because Quicklisp isn't available in my run SBCL-sh. So give me a second here. I'm going to have to do the old-fashioned ASDIF way of actually loading this simple thing. Let's go ahead and do require ASDIF. Okay, now that we have ASDIF, let's do ASDIF load system SBCL-Librarian. And okay, let's go here. We run SBCL-sh. We run our script hello world.lisp, and we see this condition. What is this condition saying? Package during load. Oh, wait, hold on. Did I? Okay, I forgot to save. That's the problem. What is it now? ASDIF does not exist. Oh. One second. I must have done something wrong. Okay. Let me try something else here, which is one second. This one needs. Let's see something here. Okay. There's one thing that I'm missing in terms of building this, and why is it actually complaining about that? Hold on. Let me just run something here. Okay. Let me try this without this. Since we're writing it as a script, this should work. There we go. The problem is when I was doing it compile, it wasn't actually eval when for some reason. It wasn't a loading as if. I have to go and figure out why that's the case. Okay, so let's see what gets generated here. Originally, there was only one file, hello-world.lisp. But now you can see what we've done is we've generated the header. We've generated a .c that implements the interactions between Lisp and C, and additionally we also have our Python module. Let's quickly just run the Python module. We'll look at each of the generated files. All right. So if we run Python 3, you do lib hello world. This should just load. What is the problem? Hold on. There's a problem. Path hello world. Trace back line 9. Unable to locate lib hello world. Oh, right, because of the fact I forgot to provide my LD library path here. I forgot to export LD library path, didn't I? Yes, I did. Let me quickly fix this, just so that you guys can see what I'm talking about without having to do. Okay, let's do this. Okay. Export LD library path equals library path. Let's try that again. Interesting, it still is unable to find it, even though it's right here, don't I? Oh, it did not generate the so file. Okay. Okay, give me a second here. There is something that I'm missing. Oh, got it. I have to first compile the actual generated C code. Okay, give me a second. So let me go look at, this is one thing I didn't recognize that. Lib hello world. .py. Well, let's look at each of these individual things. So in the generated thing, we have our exported API that does Lisp release handles. You can see our exported types and exported functions. It has our actual add available to you, and we have something called Lisp Init Core. If we end up doing lib hello world, you could see in the .c that the only thing that's actually technically defined is our init, because that's necessary for us to load it. And this is kind of the same pattern that we were leveraging to as well here in the other example that I was trying to write out. So let's go ahead and compile this guy then, if I needed to do this. Looks like according to the docs I need to do this. Let's see. In order for us to do this, we have to do cc-shared-fpic, I think it was. Yeah. Show live hello world. So, and we need to compile hello world.c, and we need to provide the location of our SBCL runtime we're trying to link against, which is located in source runtime SBCL, and now we have our shared object that if we go and try to run Python 3 import lib hello world on, should now work. Oh, sorry, I have to provide what is it, the location of our SBCL runtime. We could just copy it here and do this, and this should work. Okay, and there we go. We can at least see that now what's needed is dynamic module does not define dynamic module export function. Interesting. So in Python init, it looks like it is not able to define the generated code did not define a init function. I'm wondering if it's because I know that there is an exit here. I know here this might actually cause some failure because what happens is there's a success and failure defined in the standard library that might be clobbering. So let's see what happens. We generate the library, we compile the library, once we've compiled it, we should be able to run Python. Maybe I have to do this, Python. Okay. Oh, no, Python 3 is the one that I need to run. Okay, import hello world. Interesting. I'm wondering if the problem is eShell. Let me see something. Might be an issue with me trying to run this through eShell. So let's see if I could get this here set up so we could do just normal shell. like there is something missing in our generation when we're trying to run. See something here. Let me try and see this. Copy. So the issue that you're seeing here, this PyInit, does not define module export function, is telling us that there might be an issue with how our libhello.py was generated. So let's go look at what this does. It created the proper error handle. It created libl value. It generated all of the name symbols of the dictionary as it's supposed to, but it does not define PyInit lib hello world. Okay, so there is something there specifically that's missing in order for us to actually get this to work, at least on Debian 11 with SBCL-242. Let's try. Ooh, yeah. Let me try one other thing. According to this, we have Roswell source SBCL-233, but it doesn't have 241. Let's see if I could get 241s. Roswell run. Let's see if we could get my version. SBCL-bin 242, I think it's called. Okay. We built it. Let's see if I could do it this way. Roswell source. Okay, so it now has SBCL-242 here. Let's see here. Okay. And let's see, ls source runtime. Okay, it does not have the source code there, but let us see if I can run and try this instead. Let's do home.roswell source SBCL-242 Linux. Okay, and let's go back to software list projects. Hello SBCL-Librarian. Okay, let's get rid of this. And let's also get rid of .core.c.h.py. So essentially we're back to where we were before. Now let's go ahead and run SBCL source run script hello world.lisp. Now this is running a different version. let's see if I can get the compilation going with our things, because if this works, it tells me that it's an issue with my compiled version of SBCL, which I will openly attest to being potentially a problem, but we will see. Okay, cannot find that. All right, let's see. Well, that's natural because we can actually see it in there. Let's see. Source SBCL2. Okay, do they have? Okay, that's what I need to run. I'm running the run. I have to do run Roswell SBCL source 242. There we go. This will work. Now we got it, and once I do that, this is going to be in. Let's go ahead and load. We're going to have to load. We're going to have to update the path to the sources. Okay, so let's do that. Export path. So what I'm doing is the issue is it seems to be my actual install. I kind of figured that would be the case of how I built SBCL from source. So my shared object isn't doing what it's supposed to do. That's why everything else is kind of working incorrectly. So I'm just trying to fix that while we're working on this today. Sorry for folks who are just joining us. We're just in the midst of a bit of a debugging session. Roswell, Impulse, x86, 64, Linux, SBCL bin, or 2. I think it's bin. Okay. That's good. Now let's go into Roswell source SBCL 242.linux. Okay, and in here, we go to source, we'll have, oops, not there. I have to go into not here, not ECL either. Go to Impulse. Sorry if you guys are wondering why I keep on going, it's because autocomplete for some reason keeps on trying to be smarter than me on Emacs, and I haven't fixed it yet. Linux, SBCL, bin, 242. That's not it. Where did they put that stuff? You actually get SBCL source / Archive is in archives. Okay. Archives. There we go. Tar XBCF. SBCL bin. Wait. Not SBCL bin. SBCL 242. Okay, so now we need to go and build this guy. Make config.sh fancy. Fancy we need to build because just so that folks know, SBCL-Librarian requires like lib, I believe ZSTD for compression, and that only seems to occur when you run in fancy mode in this. Okay, so make config. Okay, I'm going to have to run this in a shell, so let me go and switch into a shell for you folks. Give me a second. Okay. Second. And okay. And do that. There we go. Share. And let me do this. Terminal. There we go. Okay. Give me just 1 second here. Perfect. All right. So let's do this. I'm going to have to do the same stuff here. SBCL equals. Oh wait, let me go back to Roswell archives. SBCL 242. You can see that we have to do. Oh, we have to also. I have to set up my environment here too as well because I didn't do this earlier. Trying to use our source is going to be, well, our path is going to be, actually, go back to this here for a second. Yeah, our path is going to be $home/.roswell/ what is it? Oh, impulse x86-64 SBCL. Oh, Linux. Oh, wait. Linux SBCL bin 242. For some reason, I have to go into. Okay. 242/bin $path. Okay. Export is there anything else I need to do in here? No, I shouldn't have to. Okay. And let's see what it gives us. Okay, we're good. Let's go ahead and now do make config sh-fancy here. Everything's clean. Okay. Now we need to do 1 second here. Looks like there we go. And now we need to do I think make. This is going to take a little bit of time. Wait, there is something that it did. Git describe to fix this, either install git or create. Huh. Cannot figure that out, huh? Alright, fine. Okay, do this. we go. And this is going to take a little bit of time just because it's compiling, obviously, the entire Lisp kernel. And then we could just create the shared library. This shouldn't take any more than a few minutes. In the meantime, I'm just going to kind of just reiterate what I was trying to kind of go through. The main things that that take away is if everything is kind of worked well. You can see that the auto generation of the code is pretty quick. It'll generate a very nice C API for you from your Lisp API. It's just a matter of compiling this library and now being able to run it. The one thing to note, while this is actually working, let me switch back to something that we encountered earlier, and that is, let me go back to our eShell here, is switch over to this. Sorry, today's been kind of a switch between different things. We saw before that, let's go back to, no, hold on, in our, where is it? In our hello-world.lisp, okay, we saw that when we were generating, I believe it was here, when we're defining our API, the main thing to note here is it attempted to essentially create this, initialize alien callable symbol. So let's see if this is what is being leveraged to actually, if we can leverage this in our vanilla example to create essentially a callable function, okay? And you can see the differences between how much work that they did and what we need to do to kind of get the same kind of equivalent in our vanilla example. Math.lisp. Okay, so we have our API here that we've defined, and we've also created a mymath.core here with the callable exports. Let's go ahead and also provide essentially let's go ahead and actually let me go do this. Leverage this guy. Okay. In our code. Alright. So now what we do is instead of this, what we do is we call initialize alien callable symbols, but we call it on add. Here, like so. Undefined alien callable symbols. We defined it, we added it, unable to access. Okay, so there is something here that we are missing in our example that in this generation, we are not missing. So what is it? So it is mapping the return type here versus our return type. Okay, so let's go and try and see if we can mimic that. Result, res, and then it is a pointer to an SB alien int. this complaining about? What is the warning getting generated on? Add is getting generated on. Well, I need to run one more thing here. Let's see if this kind of works. Stop warning. Okay. And okay, I see what the problem is. Okay, so in our thing, we have to do this. Wait. Uses, do this. Just so that way I have our alien callable on here. And let's just quickly look at what the difference is here. So what he did was, we defined a function that we defined, and then I have to do this. I have to do setf sb alien dref res, and then we have to add ab here. Okay, let's see here. Attempt to access undefined aliens variable. Attempt to access undefined alien variable. It is available here. We created an alien callable. It sets up the dereferences, sets up the initialized callable symbol, then it defines the same library. So what does this guy do then? Creates a new linkage. This is not a macro, this is not a macro. This is generating our environment. This is generating our source code as I showed you guys earlier, and it's calling, in this case, our add function that we defined as a simple Lisp function, but we're exporting it out. So the problem is, maybe I have to do this. I cannot do, in my example, sorry, I have to do not only this, let's add AB here, and here, do alien add, or my math add. let's see if our shared library is finished here. Okay, it is. Let me change things up here. Let me just switch the quick back here to this. And for folks who are in that, go to here. Okay. And it is slightly here. Just need to expand it. Alright. So let's go back to what we were trying to show you here for SBCL-Librarian, using the example that we provided, and we need to recompile our code here using this. Okay, and remember we saw this here. Let's go ahead and compile. Well, hold on, let's echo SBCL source runtime just to make sure that we're in. Okay, so we're in the wrong runtime right now. So let's export this guy. SBCL source is going to now equal home Roswell impulse x86 64. Oh, no, not, it's going to be archives, actually, archives, SBCL 242, and this should be good. So let's make sure source runtime is there, perfect. Let me just also ls this guy to make sure that our libso is there. It is. Good. Now we can actually compile this code following this command here. And we have our so file. Oh, there's a question. Alright, please type your questions. What terminal is this? There's a question here. What terminal am I using? I'm using bash inside Debian 11. This is holding our example that we written earlier that's using SBCL-Librarian. It contains earlier, if you recall, we ran this script and we generated our lib hello world.c file and our .h file that we're now compiling using a newer version of SBCL that I just compiled in the last few minutes.
But what's the terminal surrounding the whole thing?
It's bash.
Like the shell is bash.
Yeah.
The terminal is...
Are you talking about the application that I'm using?
Yeah, what application is that?
Oh, okay. The terminal application I'm using is it's not KTerm. It's the terminal application that's for XFCE. I'm forgetting the name off of it. It's the default one.
Oh, okay.
I'm not using like iTerm or anything like that. I didn't get a chance to update this to use. Normally, I'm used to using like KTerminal and Qt based ones because I'm used to using KDE versus GNOME.
Yeah.
But I've been recently with Debian 11 getting adjusted to XFCE just because the APIs and the GUIs in XFCE kind of grown on me, and I like the simplicity. But I do miss KDE's terminal window just because there's a lot of functionality that I've gotten accustomed to over the years that this terminal application does not have.
Okay, cool.
All right. So the question was about, for folks who are just joining in, about terminal applications that I was using, just for folks watching in who haven't gotten caught on that reference. Okay. So I compiled this guy. This should, oh right, I need to first copy over or I could just do this. Export LD path $SBCL source. Okay. And let's try running Python 3 import lib hello world. And we are still getting this define export function. Why? That init should have been encountered by. Okay, so let's do this. nm lib hello world, and let's do grep-et init lib hello world. Oh wait, sorry. That so. Oh, it doesn't exist. Interesting. Let me see what exported symbols do exist. Initialize Lisp. We could see our lib hello add is there, but the init did not get generated. Ooh, okay. So this will work like a C library, but this will not work like a Python library, because the PyAPI bindings did not work the way as expected. Weird. Okay, so what did I do wrong here? Okay, so Python may not be the issue. The issue isn't probably necessarily the issue with my library. Okay, so let's go and quickly do something. Let's create a C file. int r and let's call this hello.c, just so I can actually get some stuff here. And let's do include lib hello.world h. And for this guy, I need the core file. Okay. Let's do this. I'm just trying to recognize what the name of the API that we already created is, and it returns a 1 or a 0 if I remember correctly. Let's see. Okay, it returns 1 or 0. Okay. So if init and the name of our file is lib hello world.core not equals 0, printf unable to load Lisp core file. Okay, let's just say this lib hello world. Obviously, if you want to change it to different files, you could certainly extend this. But return 1, sorry, not return -1. Now that that's loaded, we need to be able to call our code. So let's say we have two integers, a equals 5, b equals 2. We need a pointer to a a result that we need to pass in. So we need to do int star res equals calloc on the size of int now we need to pass this into our function lib hello add ab res, and that's going to return either error or success. So let's say err failed, and unable to call exported lib add function. Otherwise, we'll say printf result is d. Actually, let's do just to make things a little interesting, and res. Okay, so let's go ahead and compile this guy. cc-l home software projects, this projects, CFFI because where it's the littles. Librarian -l $SBCL. Oh, right. This will not work. Archives. Actually, let me just do this. Export SBCL source home Roswell archives SBCL. Then we need to do cc-l projects. This is just making it easier for me to be able to type in the source where SBCL is located. Source, the shared object, that is. World hello.c -l hello world -l SBCL. Wait a second. Can I mess up calloc's definition? Oh, not the cast. Okay. Let me just do this, include stdlib.h and star. Forgot a cast. There we go. And let's go ahead and export library.path equals this home SBCL source runtime LD library path. This is all just for setting up so I can actually run my executable. If I run this, we get core was built for runtime, but this is defined. Okay, hold on a second. Which runtime did I run this in? the problem it's complaining about is the core file. So let's do this very quickly. And let's run SBCL source run SBCL script. What is it complaining about? Oh, it's because I forgot to add source registry equals, because I've been switching between so many terminals, right? It's complaining about the fact that I forgot to add the source registry to where SBCL-Librarian is located. Home as well. Local projects. SBCL-Librarian. There we go. Let's go ahead and recompile everything. This shouldn't matter, but we're going to go ahead and do it anyway, just to be on the safe side. Then that we recompiled that, we need to obviously recompile our example. And if I try running hello world, yeah, hello world, you get 5 + 2 = 7. So, a couple things for folks who've been watching, who've been trying to wonder is the end thing about this main piece here that I wanted to show you, a couple things, is if you're running different SBCL implementations, we saw this in the example, regardless of whether you're using the same version of SBCL, okay? I don't know why this is the case, but if you compile the SBCL data structures for the shared object, okay? So if you're creating a core that's trying to be loaded into a specific version of SBCL, for whatever reason, and I don't know what the command lines is to work this around, it's kind of checking the, I guess, the version number at the top level, the checksum or whatever, and if it doesn't match, it'll actually go and spit out, just because they're between even the same version, like if it's in the source tree and it's appropriately tagged, because of the environment that it was built or whatnot, there might be situations where the data structures or fixes may not apply in different releases, just to be on the safe side, they barf when you try to dump the core the way you did to load it into another Lisp version, Lisp executable of even the certain version. Okay, so this is one thing that you may want to be aware of. Hopefully, as more folks use SBCL as a shared object, it might be the case that Linux distributions might pick this up and offer, as part of installing SBCL, the shared object version, so that you could pick and choose whether or not you want to use the shared object to actually use it for your applications or not. They might even have different packages for this. I'm only kind of spitballing ideas in order to make sure that this particular issue is addressed. But assuming everything works and you are using the same version of SBCL and you're using the same SBCL shared object version of the one that you're building against, then SBCL-Librarian gives you a fairly straightforward way of actually dumping, as you can see, this a C library that can actually be used directly. Now, the Python version, I'm a little surprised did not work as we expected. I thought that once you built it the way it did, it would, especially since we called out to, as you saw here in our hello world.lisp example, the fact that we are actually explicitly saying run the Python bindings. I would have expected it to actually generate the appropriate PyNit calls. It might be the case, and I'm not dismissing this idea, that it's probably looking for some development library that I currently do not have installed on my system for the purposes of building Python bindings that expose the PyObject API, because this is one thing that most people getting into learning Python, especially doing Python bindings that leverages the Python C API, tend to encounter the first time, which is when you're building Python bindings, you need to install a specific package on top of Debian Linux to get the headers necessary to actually build it. I didn't, unfortunately, check to see if I have those before starting the stream today. I will go and resolve that and see if that might be the issue. But this is something that I wish the SBCL-Librarian package actually did a quick lookup and told me ahead of time, so this way I could have fixed it on the stream. But I know because of past experiences of leveraging the Python API on other different projects in the past, and especially using, say, Swig to actually create Python bindings, that this is something that is a potential reason why this is silently failing. But we do have a function C API. We can actually write stuff against the C API if we wanted to. And obviously, with the C API as is, you can actually use the same object as libhelloworld SO to write, say, a Rust crate that leverages this API and exposes it the same way. If folks are interested in this, like or subscribe to our channel, like the actual comment in the video if you want to see bindings like that, and I could certainly make a stream to show you how to write these kinds of bindings. But there are a couple of best practice there that I think we need to address. So I'm a little over time, but I'm glad we kind of finished this. Are there other questions? There seems to be a question here. Hi, what's the best or easiest over the files or folders of the files? Okay, the person who's asking this question about, so the question is what's the best or easiest way to recurse over files or folders of a file system? Is there a specific thing, like if you're asking in Common Lisp, if there is a way to do it at a high level call with like some flags? I don't think so. But Common Lisp has multi-value return directory walkers, much like other languages, to parse through the file system. If there is a specific use case that you're thinking of, like if you're trying to find something, there are some really nice tools out there. Obviously, if you're just using vanilla Unix and Linux, Find is available at your disposal. There are some newer versions of Find that I found quite interesting, like FD. I think FD is available in on multiple platforms. Another one is if you're using grep, if you're trying to grep through something, obviously grep is available to you, but with the -r option. But you can also use RG, which is ripgrep. That's the Rust version of grep. Slightly faster in performance. It does do parallel file lookups. I haven't done a apples-to-apples comparison on those though. But if it's a Lisp-specific way of doing these kinds of things, I would need to know more about what you're trying to do. And I don't know if there is a high-level call that will just do it for you by default. Other questions? All right, so that ends our CFFI experimentation for this time, at least with SBCL-Librarian. I may add one more video in this thing just because I would like to do some stuff with Rust and Rust objects and see how it interacts with Lisp, just like we did with Go. That is going to be a topic for next week. So stay tuned for next week, and hopefully we will have some more interesting stuff for you guys to join in, probably